Hello friends, welcome back. Today in this video for the subject Basic Thermodynamics, S5 BTech Mechanical, Unit number 2, First Law of Thermodynamics, we are going to discuss some important terms which will be used in the subject. So, the contents of this video are: the first is the specific heat of a substance. Next, specific heat of ideal gases. Again, that is divided into two parts, that is specific heat at constant volume and specific heat at constant pressure. Next, we are going to discuss what is a adiabatic index, that is gamma, and what is enthalpy. So, these terms are new to you. So, let us discuss the first parameter, the specific heat. Now, what is the specific heat? Specific heat of a solid or a liquid or a gas is usually defined as the heat required to raise the unit mass through 1 degree temperature rise. So, in simple words, is the heat required for a solid or a liquid to rise the temperature by 1 degree Celsius, and the mass should be unit. That is, for unit mass there should be unit rise in temperature, and that much heat supplied is called as the specific heat. So, small quantities, generally the heat supplied is given by mc delta T, that is dt. M is what? The mass, C is the specific heat, and dt is the temperature rise. The unit for specific heat is kilojoules per kg Kelvin. Now, here please remember this C value is the specific heat values, kilojoules per kg Kelvin, and here dt means the temperature difference, that is delta T. Okay, again I repeat, specific heat of a solid or a liquid is the amount of heat required to rise a temperature of 1 degree Celsius for 1 kg, that is on mass basis. It is given by mc dt. Now, let us discuss specific heat of ideal gas. Now, specific heat at constant volume. So, it is denoted by Cv, specific heat at constant volume. So, it is the amount of heat required to raise the temperature of unit mass of gas by 1 degree at constant volume. The most important word here is the constant volume. When the volume is kept constant of a unit mass of a gas and the temperature rises by 1 degree Celsius, it means that the specific heat, that is the specific heat at constant volume, and it is denoted by C suffix V, and the unit is kilojoules per kg Kelvin. Again, we have discussed this heat supplied dq is equal to m Cv dt. Here m is the mass, m is the mass, Cv is the specific heat at constant volume, and dt is the temperature difference. This is for a reversible flow process at constant volume. Again, now let us discuss what is specific heat at constant pressure, that is Cp. Now, it is the amount of heat required to rise the temperature of unit mass of a gas by 1 degree Celsius at constant pressure. Here the word important here is the constant pressure. Constant pressure. So, it is denoted by Cp, and the unit is kilojoules per kg Kelvin. Again, the equation is dq m Cp dt. Again, dq is the heat supplied, m is the mass, Cp is the specific heat at constant pressure, and dt is the temperature difference. Now, this is again for a non-flow process at constant volume. Now, let us discuss what is a adiabatic index. Now, adiabatic index gamma, it is the ratio of specific heat at constant pressure to the specific heat at constant volume. So, it is an index or a ratio. So, gamma is Cp upon Cv, the ratio, specific heat at constant pressure to the specific heat at constant volume. Now, Cp is always greater than Cv. So, gamma is always greater than 1. Okay. So, gamma is equal to 1.4 a diatomic gas, whereas gamma is 1.67 for a monoatomic gas. Now, the next term we are going to discuss is the enthalpy. Now, what do you mean by enthalpy? So, it is defined as, enthalpy is defined as the addition of internal energy plus PV, that is the PdV work plus the internal energy. So, that is the enthalpy in simple words. In above equation, U, P and V are point functions. So, these are the point functions, remember this. They represent the property of the system, and therefore, H also defines the property of the system, very important parameter. Enthalpy is a property of the system because P, V and U also define the property of the system. Now, for a unit mass of gas, we can write small h, that is enthalpy, is equal to U, that is internal energy, plus P V, pressure and volume, where H is the specific enthalpy and U is the specific internal energy of the gas. So, H is a intensive property. The combination of U plus V plays an important role for analyzing the problems in the case of open system where matters cross the boundaries of the system. So, this is again a very important parameter you need to remember. Always U plus PV plays an important role for analyzing the property of a system. So, again for this video, I have taken R.K. Rajput, Engineering Thermodynamics, Lakshmi Publications as the reference book, Onkar Singh, Applied Thermodynamics, New Age Publication, 3rd edition. Thank you friends, thank you very much.